Hi you guys, it's Mrs. Palmer for those of you who haven't met me yet. And also some of you have not seen me without my mask before, so I may look a little bit different than you thought I did. But this is your first video lesson for Math 7, and I'm so excited to be able to teach you all about the real number system. As you are going through this video lesson, please make sure that you have a piece of paper out and something to write with, and that you have nothing that is going to distract you as you are trying to learn everything about real numbers. Now, I'm going to go ahead and pull up the slide with our learning goals. These are all of the things that you are going to learn during this lesson, and when you get done, I want you to come back to this list, and I want you to ask yourself if you know how to do all of these things. And if you don't know how to do all of these things, I want you to make sure that you make a note to yourself of what you need extra help with so that you can ask me about that either in class or through email. You are going to have to be responsible for your own learning a little bit more this quarter than you have been in the past. Okay, so these are our learning goals. Like I said, at the end of this lesson, I want you to come back to the learning goals and make sure that you know how to do all of these things. These are going to be the things that you are going to be tested on for this unit. Okay, so let's go ahead and just start with the number line. Okay, the number line is something that you guys have seen before. The number line is a horizontal line. It extends infinitely in both directions. As you move from 0 to the right on the number line, you can see that the numbers are positive and they increase in value. As you move from 0 to the left on the number line, the numbers are negative and they decrease in value. Okay, so that means that -9 is of less value than -3. Okay, it also means that 8 is of more value than 2. Okay, so as you move from 0 to the right on the number line, the numbers increase in value. And as you move from 0 to the left, the numbers decrease in value. Okay. Now, one of the things that you need to be able to do after this unit is you need to be able to classify real numbers as natural, whole, integers, rational, or irrational. Okay, so let's just talk about that for just a second. Any number that is a natural number would be considered one of the counting numbers. So the natural numbers are the very first numbers that you learned when you learned about numbers. Okay, so when you learn to count, you always learn to count with 1 first. Natural numbers start with 1, okay, and go up from there. Whole numbers are just like natural numbers, except for whole numbers include 0. Okay, so whole numbers, those are all of the natural numbers and 0. Now, when we talk about integers, you can see that the set of integers includes all of the whole numbers. Okay, so 0, and then all of the positive whole numbers. And then integers also includes their opposites, or all of the negative whole numbers. Okay, so integers are positive and negative whole numbers. When we say whole numbers, that means not a fraction or not a decimal. It's a whole number. It's not part of a number, it's a whole number. Okay, so natural numbers start with 1, they're your counting numbers. Whole numbers start with 0 and include all of the natural numbers, and then integers are the positive whole numbers and their opposites. So when we look at this number line right here, this number line is showing us the set of integers from 9 to -9. Okay. Now, some numbers can be classified in more than one system. Okay, so for example, let's say we pick the number 4. Okay, we would say that 4 is a natural number, 4 is also a whole number, and 4 is also an integer. Okay, so the number 4 can be a natural number, it can be a whole number, and it can also be an integer. So I'm just going to put an I for integer. Okay, let's look at the number 0. Okay, the number 0 is not a natural number, but it is a whole number, and it is also an integer. Okay, so 0 can be classified as a whole number and also an integer. Now let's pick one of our negative numbers. Let's pick -6. Okay, now -6 is not a natural number. It's not one of the numbers that you learned to count with. Okay, it's also not a whole number because whole numbers are 0 and all of the natural numbers. -6, though, would be classified as an integer. Okay, so when you're classifying numbers, you need to realize that they may have more than one classification. Okay, now there are another set of numbers that we need to talk about, and those are rational numbers. Okay, rational numbers are any numbers that can be written as a fraction. So if a number can be written as a fraction, then we would classify it as a rational number. Okay? Another stipulation for rational numbers is that the denominator cannot be equal to 0. In math, anytime you have a denominator that is equal to 0, we call that undefined. Anytime you're trying to divide by 0, you can't do that. That's called undefined. Okay, so when we talk about rational numbers are any numbers that can be written as a fraction, and the denominator cannot be equal to 0, because if the denominator was equal to 0, that would be called undefined. Now, I have given you some examples here of rational numbers. So we just talked about the fact that rational numbers can be written as a fraction. So as you look across this list, you may say, okay, 1/2. I can see that that's a fraction. What about 8 though? 8's not a fraction. 8's a whole number. We could classify 8 as a natural number, a whole number, and an integer. And actually, 8 can be written as a fraction. Anytime you have a whole number and you want to write it as a fraction, you just put it over a +1. Okay, so the way that you write 8 as a fraction is you put it as 8 over 1. So 8 is a rational number because it can be written as a fraction. So when we're classifying 8, we would also say it's a rational number. Okay, now when we look at 5/3, 5/3 is a fraction already. The square root of 4, okay, the square root of 4 is 2. When you find the square root of a number, you're looking for the number that multiplies by itself to get to this number that's underneath the radical sign. Okay, so because 2 is multiplied by itself to get to 4, the square root of 4 is 2. Okay, now 2 can be written as a fraction by putting it over 1. So when we classify 2, we would say it's a natural number, it's a whole number, it's an integer, and it is also a rational number. Okay, 7 1/9, we would classify that as a rational number. Obviously, it's a fraction. -12. -12, well, we know it's an integer. Okay, and it's also a rational number because -12 can be written as a fraction by putting it over 1. So -12 can be written as a fraction, so we would say -12 is also a rational number. Okay, this one right here looks kind of tricky. Square root of 64 over square root of 65. Well, not really. The square root of 64 is just 8, and the square root of 25 is 5, and that's because 8 multiplied by itself gets you to 64, and 5 multiplied by itself gets you to 25. Okay? So 8/5 would be classified as a rational number. Okay, the next one, 6.25. Another way that we can say this is 6 25/100. And actually, I'm just going to write that, 6 25/100. So this is, in fact, a rational number. This can be written as a fraction. And then the last one is a repeating decimal. And decimals, if they're a repeating decimal, can always be written as fractions. That's not something that we're going to learn in Math 7, but you do need to know that repeating decimals can be written as fractions. Okay. Now, rational numbers also have a certain location on the number line. So as we look at this number line here, we can see that there are a whole bunch of different rational numbers that are represented here. So one thing I want to point out is that we have a negative 9.5 here, okay? And you may say, well, that's a decimal, not a fraction. But negative 9.5, we can write that as a fraction. 0.5 is equivalent to 1/2. So negative 9.5 is really just negative 9.5. Now, negative 9.5 would be classified as just a rational number. It's not a natural number, it's not a whole number, and it's also not an integer, okay? Remember, integers are positive or negative whole numbers, or positive numbers, whole numbers and their opposites, okay? So the only way to classify negative 9.5 would be as a rational number. Negative 7, though, could be classified as both an integer and a rational number. And remember, if we want to write negative 7 as a fraction, we would just put that over 1. Okay. Negative 3 1/2 would be classified as a rational number only. 2/3 would be classified as a rational number only. 5/2. Okay, this is what we call an improper fraction. Anytime you have the top number bigger than the bottom number, we call that an improper fraction. And to change an improper fraction into a mixed number, we would take the top, 5, we would divide by the bottom. 2 fits into 5 twice. 2 times 2 is 4, which leaves us the 1 left over. So 5/2 is really just 2 1/2. And that is a rational number, okay? And then we have the number 5. 5 is a natural number. It is a whole number. It is an integer, and it is also a rational number, okay? To write 5 as a fraction, you would just put it over 1. The square root of 49 is 7, okay? So 7 is a natural number. It's a whole number, it's an integer, and it's also a rational number. To write 7 as a fraction, you put it over 1. And then the last one that we have is 9.3. It's a repeating decimal, and you're just going to have to remember that I told you that if a number is a repeating decimal, it is a rational number. And actually, the repeating decimal of 0.33 repeating is really equivalent to the fraction 1/3. So if we want to write 9.3 repeating as a fraction, we could write it as 9 1/3. Okay, now there's one last classification of numbers that we need to talk about, and that is irrational numbers. Okay, rational numbers can be written as fractions. Irrational numbers cannot be written as fractions, and that is because irrational numbers have a decimal that doesn't ever repeat and that doesn't ever end. So there's no way to write an irrational number as a fraction. So right here, if you look at the square root of 8, you can see that that decimal never repeats and it never ends. If we look at the rational number of negative square root of 15, you can see that that decimal never repeats, never ends. If we look at the square root of 2/3, you can see that that decimal never repeats and never ends. And then the last example is pi. I think this is something that you guys are probably familiar with. But pi is also a never repeating, never ending decimal. So irrational numbers are numbers that cannot be written as fractions. One thing that you need to know is that a number is either going to be a rational number or an irrational number. It can never be both at the same time. Okay? So let's go ahead and look at this number chart just quickly as a review. Our natural numbers are all of our counting numbers. Our whole numbers are all of the counting numbers, including 0. Integers are our positive and negative whole numbers. And then rational numbers are any numbers that can be written as a fraction. Okay? So if a number is a whole number, it is also a natural number. Okay? If a number is an integer, it is also a whole number, and it is also a natural number. And if a number is a rational number, it is also an integer. It is also, well, not necessarily an integer. Sorry, let me take that back. So if a number is a rational number, it may possibly be an integer or a whole number or a natural number. But if it has a fraction or decimal part, it's only a rational number. Okay, at this point in the video, I need you to go to your Canvas course. And in your Canvas course, there is a learning activity called the Venn diagram. So I need you to go to your Canvas course, click on the Venn diagram, and you are going to complete the learning activity for this particular topic. Okay? If you're having any questions about how to classify numbers, at this point, please make sure that you come and ask me any questions that you have, because as you're going through this lesson, I'm not with you. You may be in class watching the lesson at your desk, or you may be at home watching this lesson on your own. But either way, you are the only one who knows if you're understanding this or not. So if this is something that you are struggling with or you need a little bit more help with, at this point, I need you to ask me for that help. Okay? And with that said, I will see you in the next lesson.